Yeah, all right, guys, you're all welcome. You're welcome to another live section. And just so you know, we are still on the SAT advanced section. We're still solving problems on the SAT advanced math section, and all the problem we are solving here, they are already solved questions. So we kind of are doing reviews and seeing how we can solve these questions real fast. That is the idea of this live stream. We want to see how we can solve most of these problems real fast. So we'll be integrating the Desmos graphic calculator in this particular live stream. So guys, if you're joining us from any part of the world, kindly just tell me on the comment section where you're joining us from. I would like to know you and I would like to have a conversation with you. Possibly if you've written the SAT before or if you're planning to write the test. I would like to know your get to know your experience, and also others may want to hear. So guys, you're all welcome once again to the live stream. We are so excited to have you here again, and we're going to just move on straight up from where we stopped on the previous live stream. So we're going to just continue from where we stopped. Okay. So guys, the next question we would want to solve here is question 11. That is the next question we might want to solve. Question 11, okay? So I want you to read question 11 as much as you can. I'll just give you only 1 minute to just attempt this question, and once you have your answer, you can put it down on the comment section. So your time starts now. Question 1. All right, so guys, kindly drop your answer in the comment section. What do you think the answer is for question 11? What do you think question 11? Remember the condition for T. T has to be positive. So what do you think your answer is for question 11? Kindly put down your answer in the comment section, and that would help us a lot. Okay, this is fine. There's no answer coming up right now. So I think because of time, we might just have to do it ourselves, and we move on from there. So this question, is it Desmos compactable? Can you solve this question using the Desmos graphic calculator? Is it possible? Yes, the answer is yes, it's possible. You can actually solve this question with the Desmos graphic calculator. So, and that is even way much faster than solving it manually. So I'm going to show you how to solve this same question with the Desmos graphic calculator right away. So now let's go over to the Desmos graphic calculator. So this is the interface, okay, of the Desmos graphic calculator, and you want to just put in the equation right here. So we have 3 over t plus 1. So that is the first expression we've got, 3 upon t plus 1. and then we have equal to 2 over t plus 3. So this is what we have again, t over 2 plus 3. So it's pretty much easy to impute this equation. So if you've not done that before, you can just take your time and do a lot of practice. Just go ahead and play around with the decimals calculator, and of course you'll be good with it. Then we have plus 1 over 4. Plus 1 over 4. So we've just imputed the whole equation on the decimals graphic calculator, but it seems to have an error sign here. You can see this sign here. This is kind of an error sign, or a caution sign, rather a caution sign. So what is it saying? It's just trying to tell you the variable t is not usually recognized on these decimals. The variable that is recognized on the decimals is the variable x and y. So if you're using a t, then it has to come with a slider. So that means if I decide to change this t to x, let's see what it looks like when I change t to x. Let's see if we have that. Okay, you see now, when I change t to x, you can see the whole equation just worked out. So guys, I prefer translate the equation that is given to you into x or y. That would make a lot of sense depending on the question given to you. So now let's go over to the chart. Remember, we want to find the value of t, and that value of t now is the value of x. So we go to the x axis and look for where it intersects with the x axis, where the curve, you can see the curve. This whole stuff here is the curve. These red lines, they are the curve. So we are looking for where it intersects with the x axis, right? And if you look closer, it's actually at the point minus 5 and 5. You can see it, but it's actually at the point minus 5 and 5. So the value of x is minus 5 or 5. So invariably the value of t is minus 5 or 5. So that is pretty much how to go about this problem. So remember, the value of t is equal to 5 or minus 5. But remember the condition that was given to us earlier. It says t has to be positive. Because t has to be positive, we are going to neglect this solution and we will always consider this solution for the question. I hope it helps. So this is how to solve question on SAT using the decimals graphic calculator. So one thing you want to make sure you get used to is how to interpret graphs. You want to master how to interpret graph, because that really help you so much when it comes to using the decimals graphic calculator. Help you so much. So guys, that is that for that particular question. Do you have any doubt? Do you have any question? If you do have any question, just put it down in the comment section so that we can review it together and see how to go about the solution. So this is just solving this whole problem with decimals graphic calculator. I hope it's clear. Okay guys, so I think that particular question is clear, but if you're watching this class after the live stream, just go ahead and put down your question if you have any. Then later on I will go back and check the comment section, and hopefully in our next live stream we'll have to address the questions on the previous live stream. So just go ahead and put down your questions. They will be addressed in the next live stream. So guys, let's move on to the next question on our chart. Yeah, so this is another question again. You don't want to start attempting manually. It's going to take you a lot of time to solve this problem manually. So all you want to do is to solve this problem using decimals. So decimals will give you a quick answer when it comes to solving problems like this on decimals graphic calculator. So guys, let me know what you think about this particular problem, example 12. What do you think? Is this something you can do without the decimals? Will it be much faster if you solve this question without the decimals, or what do you think? Let me know in the comment section. So guys, it's just a minute and some seconds. What do you think your answer is? Put it in the section and we'll review it all together. So I think right about now, let us go ahead and solve this problem with the Desmos graphing calculator. I would not want you to start taking your time solving this problem manually. It's going to take you a lot of time. And in the SAT, you don't want to joke with your time, right? So let's solve this problem with the Desmos graphic calculator. So here we have 3x plus y is equal to minus 3. So we just go right here. So you can clear up this one and paste 3x plus y equal to minus 3. So 3x plus y equal to minus 3, right? So that's the first equation we've got. You can see the line right here. You can see the blue line right here for the 3x plus y equal to minus 3. Now the next thing you want to do is to now put in the other equation. So let's put in the other equation. So we have x plus 1 squared minus 4 minus 6. X plus 1 squared. Let's go to x plus 1 squared. So we'll put it in bracket first of all. X plus 1 squared. So that's what we have. X plus 1 squared minus 4 x plus 1 minus 6, okay, equal to y. So I think this is what we've got. Let's quickly do a quick check. Yeah, minus 4 minus 6 equal to y. Minus 4 minus 6 equal to y. So this is what we have. You can see this one, this second equation is having the green color. So that's this curve you see in this parabola you're seeing that's opening upward. So that is what the second equation is. Now your interest here is not where it caught the x-axis. That's not your interest, because you have two equations right here. You're looking for the point where the two curves intersect, not the point where it caught the x-axis. So you get it. You're looking at that point where the two curves intersect. So that's this point and this point. So not this point, not these ones. These ones are not part of it. These ones are not part of it. So we're looking at this curve, this point, and this point. That's the solution to this problem. So let's quickly go back to the chart and see what we have. Now it says if x comma y is a solution to this of the system of equation above and y is positive, take note again, they need you to find the positive value of y. What is the possible value of y? But y has to be positive. Okay, so this is the x value and this is the y value, and in this other point this is the x value and this is the y value. You can see the y value here is negative and the y value here is positive. Remember, we are interested in the y value, right? And we want the y value to be positive. So that means the answer to this question is going to be 6. You see how easy it is, right? So the Desmos is going to save you a lot of time. So if you know how to interpret or how to read charts or graphs, that would help you a lot. That will help. So guys, that is it for this particular question. If you do you have any doubt? If you do, let me know in the comment section. If you have questions, if you have suggestions, just let me know in the comment section. Okay? Okay, perfect. So guys, particular question, that's it for that particular question. So we are now moving on to the next question. That will be question 13. So here we go. This is question 13, or example 13 rather, and it says the graph of which of the following functions in xy plane has x-intercept at -4 and 5. So they're looking at the graph of which of these following function has the x-intercept at -4 and -5. What could that be? This is one of the most easiest question on the SAT. One of the most easiest question. And if it's not easy for you, just stay put, just relax, do what you know how to do. Before the end of this class, before the end of this video, these questions we are solving, all of them are going to be a lot easier for you because we will have to explain all of these things step by step. Okay, so when you understand the and you speed up, you become much faster. So it's going to be slow here, but we are explaining. So we are only trying to make you understand the concept. And once you do understand the concept, you build up from there and you speed up. I hope that is clear. So guys, put your answer for this particular question in the comment section. Okay, let's get started. Question 13. It says the graph of which of the following function in xy plane has x-intercept at -4 and 5. Now, whenever you hear x-intercept, the y value has to be equal to 0. At x-intercept, the y value is always going to be 0. And all these guys here are the y value, they are the y value, they are the y value. So they're all going to be equal to 0. So if you set this guy to 0, that implies that x will be equal to -4 or +5. Is it what we have here? So that's going to be the answer, -4 or +5. But if you want to try out other ones, you're going to have this one as x will be equal to um 5, and that's not what we have here. That's not what we have here. So that means this question, this second option is not the correct one. So when you try out the other ones, you see that they are not still correct. The only one that gives you the x-intercept at -4 and 5 is option A. So guys, I hope that was. If you still have questions, if you still have doubt, just kindly put it down in the comment section and we'll take it up from there. So example 13 has been solved, right? So let's move on to the next question. Okay, here we go. We have example 14. This is one of the most difficult question in this department, in this section. This is one of the most difficult question in this section. This is one of the most difficult question. But in a moment from now, you're going to see how easy this question would look like once we are done solving it. You're going to see how easy it looks like. So I want to give you just a minute to attempt this question, and thereafter you drop your answer on the comment section. So guys, what do you think? Do you have your answers already? Put it down in the comment section. If not, let us do it together. So, like I said, most of the questions in this section, they are all Desmos compatible. Most of them are Desmos compatible. So I'm going to be showing you how to solve most of these questions with the Desmos graphic calculator. That will save you a lot of time. That will save you a lot of time on the test day. So guys, you don't have to solve this problem manually. That will take you a lot of time. So I'll only show you how to do this. Okay, you can still do it manually if you really understand this question. I mean, you can even still do it much faster manually if you understand how to interpret graph. But so guys, let me show you how to do it with the Dexmos, and that will be a lot faster. The question says, the function f of x equal to x to the 4 minus 2.4x squared is graphed in the xy plane. This is the graph. This is the graph of that function x4 minus 2.4x squared. This is the graph. Okay, you can see the graph looking like a W bar, a double bottom graph. So it says if k is a constant such that f of x equal to k, this thing is the same as saying y equal to k. Okay, and it has four solutions. Which of the following could be the value of k? In other words, we're looking for the value of k that will make this system have four solutions. What does it mean for a system to have four solutions? Remember, this is the first equation. So we're looking for another equation that would make this whole system have four solutions. What you should note is the number of intersection determines the number of solutions. Just like you can see this one here, this one we just finished graph. You can see these two equations, they intersected on 2 points. So that means this system have just two solutions. The number of intersections determines the number of solutions. So for us to look for the value of k that will make this system have four solutions, in other words, it has to intersect with this curve 4 points at 4 sides or at 4 angles or whatever you want to call it. Okay, so now the first one here is like y equal to 1, because we're looking for the value of k. So if this one is correct, that will be y equal to 1. If this one is correct, that will be y equal to 0, or f of s equal to 0, any one you want to call it. And if this is correct, this will be y equal to minus 1, and finally this will be y equal to minus 2. Of course, if you plug y equal to 1 in this graph, that's going to be like this. That's going to be like this. This is the line y equal to 1. This is the line y equal to 1. And you see it has only two solutions because of it has two intersections. The number of intersections determines the number of solutions. Because there's just two intersections here, then this system have this line has only two solutions, but we're looking for the four solution, not two solution. Okay, so if we draw the line y equal to 0, that's going to pass through the x-axis, and let's see. So this is a line y equal to 0. So what do you observe? It actually has three intersections, so it has three solutions. It has three intersections. You can see the first one is here, the second one is here, and the third one is here. So three intersection, three solutions. Remember, we're looking for four solutions, guys. Four solutions. So the next we want to do is to draw the line y equal to minus 1. So that we pass through here. This is the line y equal to minus 1. You can see it, right? So this is the line y equal to minus 1. What do you observe? It has 4 points of intersection, 1, 2, and 4. So because it has 4 points of intersection, then it has 4 solutions. So this is the line that will make this system have 4 solutions. So the correct answer is going to be this one. So just before we even stop checking out the other ones, let us even see what this last one would give us. So y equal to minus 2. So if we draw the line y equal to minus 2, what do you observe? It never even cut the other curve. Y equal to minus 2 never cut the other curve. What then does it mean? It's that point where the system has no solution. So if they've asked us, what's the value of k, whereby the system has no solution or zero solution, then the answer is going to be -2, because at -2 the system has no intersection, and that means it has no solution. But that's not the question. The question is asking for 4 solutions. So the correct answer is going to be C, when y is equal to -1. Yeah, this is exactly how it's going to be if you graph it on the Dexmos. It's only just going to be much clearer, and you see the lines properly if you do. I will advise you go ahead and do the task. Graph the first equation, which is this main equation. Then you go ahead and graph all of these ones, and you see how they are cutting the curve. And you definitely see the number of intersection, which corresponds to the number of solution. And you finally did see that the answer will be -1. So that's the value of k, guys. That's the value of k. Do you have any doubt? Do you have any question? Please go ahead and ask your question. All right, I think that one is taken. Go to the next question. Okay, so this is the next question, is under functions, example 15. This is the next question, and it's actually under functions. And this one is very quite interesting, very easy. We are given that g of x is equal to 2x plus 1, and we're given that f of x is equal to g of x plus 4, and then we want to find f of 2. You should know that f of 2 will be obtained from f of x. So that is what you should do. We have to obtain f of 2 from f of x. So before we even start finding f of 2, it will make sense that we simplify f of x properly, because we already know what g of x is. So instead of writing g of x, I will just replace it as 2x plus 1, then plus the 4 that was here earlier. So that's going to become f of x is equal to 2x plus 5, right? So right about now, we can now find f of 2. So f of 2 simply implies replacing x as 2. So wherever I see x in the expression, I will just replace it with 2. So 2 times 2 is 4, and 4 plus 5 would give us 9. So the answer to this question would be 9. So guys, that is the end of that particular question. It was quick, and it was very straightforward. I wish all the question on SAT is going to be like this. Yeah, so it was quick and it was just straight to the point. So guys, at this very point, we are almost coming to the end of the live stream. So if you are already enjoying this live stream, make sure you give us a good thumbs up, hit the like button on this video, share this video link to other people who are interested in joining the SAT live stream class. Share the video link to them, and I'm sure they're going to learn a lot from this live stream. That's going to be a lifesaver, I bet you. So now let's take this last question and we close for today. It says, for a certain reservoir, the function f gives the water level f of n to the nearest whole percent of capacity on the nth day of 2016. Which of the following is the best interpretation of f of 37 equal to 70? Now, what you should look out for is f of n. The n there represents nth day, and the f of n is to the nearest whole percent capacity. So this guy represents whole percent capacity. So that's going to be like, on the 37th day, the water level of the dam was 70%. This one talks about the nth day. So let's see option A. Option A says the water level of the dam at 37%. No, it's not 37%. It's 37th day. So this one is wrong. This one is saying the water level of the dam was 70%, which is good, for 37 days. No, It's supposed to be on the 37th day. So for 37 days and 37th day, they are not the same. So option C says on the 37th day, which is correct, the water level of the dam was 70%. And the other one is on the 7th day, so this is wrong. So the correct answer is going to be option C. So guys, this is what it is. I'm sure you're already understanding this concept. I'm sure it's getting clearer. I'm sure you're understanding this class. Okay, let's see if we can just do one more or two and we'll close the live stream. Yeah, we already had a first live stream today, so a lot of our students, maybe they are or they are not back from their activity. So that is why it is what it is now. But it's all good. It's all good. I'm sure you're going to watch live stream after now. Do well to watch the live stream. And if you're watching the live stream after the live section, if you have questions, just put it down in the comment section. Just put it down in the comment section. That is perfect. That is fine. So guys, let us continue. Okay, let us continue. So it says if an object M is moving at a speed V, the object kinetic energy is given by this equation. So this equation is a very familiar equation. Ke equal to half mv squared is the equation of the kinetic energy of a body, right? So now let's read it. It says if the mass of the object is halved, so the new mass now is now halved. That would be m over 2. That's the new mass. That's the new mass. Okay? So, and again, the speed is now double. The speed is v. So, when you double the speed now becomes 2v. So, they are asking us, how does the kinetic energy change? So, that means the kinetic energy now for this change will be half mv squared. But the m is now half, so that will be m over 2. And the speed is now double, that will be 2v all squared. Remember, the v has to be squared, right? So we want to see how does this kinetic energy change because of this change. So now let's clean up this stuff. So that would be like 1 over 2 times m over 2 times 4v squared, right? Because 2 squared is 4 and v squared is v squared. So from here, these guys, 2 times 2 cancel out 4. And finally, what do we have? We just have mv squared. So previously, we have half mv squared, and now we just have mv squared. So that means the kinetic energy doubled. Imagine if you have half orange and now you just have just one orange. What happened? This orange doubled to give you one. So that means the kinetic energy doubled to get this particular quantity. So the answer will be C. Kinetic energy doubled. Okay, let's see if we can just close the live stream exactly at 40 minutes. Let's see if we still have one more question to solve. Okay, let's just solve this last question and that will be all for today's live stream. So guys, if you're finding value from this video and you want more of this content, just kindly subscribe. That's the only way you get to see us often, and turn on the notification bell so that whenever we go on live like this, you'll be the first to be notified. And again, if you are already finding value from this video, make sure you also share this video link to other people, to other learners in their group chats and wherever they are. Just go ahead and share this live stream. That be a lifesaver, I tell you. So now this question, the last question for this very live stream, it says a gas in a container will escape through holes of microscopic size. As long as the holes are larger than the gas molecules, the process is called effusion. If a gas of molar mass M1 effuses at rate R1, all of these things are not true. I mean, they are taking us a lot of time reading this stuff. If you look at the whole expression, they just want you to know that this is the formula. This is Graham's, right? If you're a science student, you remember this is Graham's law, okay? And they just want you to make M2 the subject of the formula. That is exactly what they want you to do. They just want you to make M2 the subject of the formula. And you just have to go straight forward and start solving for M2. Remember, R1 over R2 is equal to the square root of m2 over m1. So we want to make m2 the subject, so we have to square both sides, right? We have to square both sides. So this square cancel out this one. So we now have m2 over m1 is equal to, this will now be r1 squared over r2 squared. Perfect. So to get rid of this m1 here so that we can make m2 the subject, we multiply everybody by m1. We multiply these guys too by m1, right? So that this m1 can take care of this m1, and finally m2 is now equal to m1 into bracket r1 squared over r2 squared, and that is going to be option I think it's option A, right? You see, these things are looking confusing, so you must have to be careful. So the answer is option A. Option A is the correct answer. So guys, it's been a long time here. It's been a really long, sure you must have found value from this very video lesson. So not just so that you know, this is still the SAT advanced math section. So we've just come to the end of this very live stream. And of course, like I said, if you're just joining us right now and you have questions, or if you're watching this live stream after the live stream, just put down your comment, just put down your question in the comment section, and it's going to be attended to. So we've come to the end of today's class, and I wish you all the best in your SAT preparation. Make sure you watch this video and share to other learners who are interested to write the SAT, and I'll see you when next I see you. Have a wonderful day, and God bless. Bye bye.